How terrible is it for an antimatter meteorite to hit the Earth? Even if only a piece as heavy as a piano falls to the ground, the entire city can be directly lost from the map. An antimatter meteorite the same size as the meteorite of the extinct dinosaurs, once it hits the Earth's sphere, the entire Earth's sphere may be annihilated and lost, which is the terrifying power of antimatter. What is even more frightening is that antimatter meteorites may really exist in the universe. There are even antimatter stars and antimatter galaxies. Antimatter is a thing that is particularly contrary to common sense, but in fact, it is a mirror twin of ordinary matter. The two are almost identical, with only one key difference. The charge is completely opposite. Its most lethal feature is that once the antimatter and the general substance meet, they will be completely annihilated in an instant, and almost all the mass will be converted into pure energy without a trace of residue. This leads to one of the biggest puzzles in the scientific community. In the early stage of the explosion of the universe, it should have produced an equal amount of matter and antimatter, and when they met, they should annihilate each other. In the end, the universe should be empty, and there would be no Earth or Sun, let alone our human race. But in fact, the universe is filled with ordinary matter, but the antimatter is almost nowhere to be seen. Why is this? The answer is hidden in a small difference, when there are more plasmid particles than antimatter plasmids, which is roughly 1 billion antimatter plasmids, corresponding to 1 billion and 1 plasmid. It is this 1/10 deviation that slowly aggregates the remaining matter after annihilation into today's universe. And why there is such a deviation, scientists have not yet figured it out. The only antimatter we can see now is the little bit that made in the laboratory. The positrons used for PAT scans in hospitals are also small enough to be ignored, but they are not visible or represented. The universe after the Big Bang is like rolling dice, and there will always be local antimatter particles that prevail. Under the pull of gravity, these antimatter gather into the same force. It can form antimatter stars, and even antimatter solar systems. If you think about it, if there really is such an antimatter galaxy, it looks no different from a normal galaxy. Antimatter also obeys the gravitational pull, and antistars also emit light. So how can it be discovered? The only clue is the gamma ray. When the edges of antimatter galaxies and the general matter between the stars meet, annihilation releases characteristic gamma rays. In 2021 years, the Philippine Gamma Ray Telescope discovered 4 objects in the Milky Way that conform to the characteristics of antistellar. If these are true antistars, then the ratio of antistars in the universe to ordinary stars is about 1 in 400,000. Seeing this, have you already thought that since there are antistars, there must be anti-material meteorites, right? In fact, as early as 1940 years, that is, only more than 10 years after the concept of antimatter was discovered, the physicist Liu Yongzhi guessed the existence of antimatter meteorites. He thought that only if our Taeyong system passed through the antimatter galaxy, the gravitational pull of the Taeyong could pull the antimatter meteorites at the edge out of the orbital path, throw into our Taeyong system. Antimatter meteorites cannot be formed in the Taeyong system, because they will be annihilated by the surrounding general matter as soon as they emerge. But in the near-real space of the stars, if it does not collide with it, it can float straight ahead. And the question arises, even if there is really an antimatter meteorite coming towards the Earth, can it break through the atmosphere? The encounter of ordinary meteorites passing through the atmosphere is much worse than this. Every time it touches a large particle, it will annihilate with the other party, and if you want to know whether it can land or not, you have to settle the account. At this time, Einstein's E equals m to mc squared. Looking at the barrier force of the atmosphere, 90% of the atmosphere of the Earth is concentrated below 1/6 kilometers, and there is more than 10,000 kilograms of air in the atmospheric passage of 1 meter square. For an antimatter meteorite to fall to the ground, the mass must first withstand and the annihilation of these emptinesses. The density of the most common chondrite meteorite is calculated as that the density of antimatter meteorites is about 3/4 kilograms per cubic meter. Scientists have calculated 27 cubic meters of antimatter meteorites with a total mass of about 90,000 kilograms. When passing through the atmosphere, it will be annihilated with more than 90,000 kilograms of air, and only more than 6,000 kilograms will be left to fall to the ground, which is almost the weight of a large piano. With this antimatter weighing more than 600 pounds, the power is so terrifying that you will never imagine it. It is also calculated that 600 kg of antimatter will be annihilated by E equal to mx square, and will be released 4 times 10 is the energy of 19 cubic glue. After it hits the ground, it will continue to annihilate with the general material on the ground, and its energy will directly double to 10. 8 times 10 square glue. Compared with nuclear bombs, the energy of a 1 trillion ton nuclear bomb is 4. 8 times 10 to the power of 15 is compared to 2. The largest nuclear bomb ever detonated by mankind, the Tsar's bomb, has an equivalent of 50 trillion tons. The energy is only 2.09 by 10 to the 17th power. This piano is heavy antimatter and is 5,000 times more powerful than a Tsar bomb. The Tsar bomb could flatten all towns within 55 kilometers, destroy all the wooden houses 160 kilometers away, and even shatter the windows of Norway and Finland. If these 6,000 kg of antimatter were smashed in Texas, the entire state would be directly destroyed. The central area was instantly gasified, and the entire surrounding area was reduced to ruins, not to mention the more than 90,000 kilograms of mass it has annihilated in the atmosphere, and those energies will spread out, and the entire United States will suffer. This is just an antimatter meteorite the size of a car, and if it comes at a height of 1,000 meters, the Earth will fly away with ash and smoke, and there will be no slag left. Seeing this, don't you instantly feel that the threat of ordinary meteorites is not worth mentioning? But don't panic, we are actually safe. NAS attracts more than 40,000 small near-Earth stars, and none of them are antimaterial. The reason is very simple. Space is not the absolute true space, and there are tiny interstellar dust floating everywhere. Every time an antimatter object touches a speck of dust in the interstellar space, it will annihilate a little, and its life will last for only 3,000 years. The last time the human solar system passed by other stars was Schultz 70,000 years ago. If an antimatter meteorite wants to survive to the present, it must not only avoid the collision of small stars that have existed in 70,000 years, but also avoid all the interstellar dust, which is more difficult than the big jackpot. What's more, a larger antimatter meteorite will continue to release gamma rays when it moves in the Taiyang system. Our telescope should have been discovered a long time ago, but until now, humans have never seen a meteorite like this. Not to mention the meteorite explosion, there is one thing that has always been speculated by everyone, which is the Tunguska explosion in 1908. At that time, a fireball exploded in the sky in a remote area of Siberia, and hundreds of square kilometers of forest were leveled, and the trees felt like bowling pins. People 30 kilometers away saw a flash brighter than the sun, and heard a loud thunderous sound. The scientists rushed to the scene in 1927 years. No meteorite remains were found, only a few tiny grains. Seeing this, do you also suspect that the Tungus explosion was carried out by antimatter meteorites? Don't think too much. Scientists have proven that this probability has nothing to do with antimatter matter. In the past, this is a mystery that has been stirred up by the scientific community. In fact, at the end of the day, although the antimaterial meteorite is terrifying, its existence itself is only a speculation based on theory. Even if there are really antimatter galaxies and antimatter meteorites in the universe, the probability of them coming to the Earth is so low that it can be ignored. But isn't the wonder of the universe in these unknowns? No one knows whether there is a world hidden in the depths of the galaxy that humans cannot see. Finally, do you feel that there are really antimatter galaxies in the universe? If there is really an antimatter meteorite flying towards the Earth, how should humans respond? Hurry up and leave your brain hole in the comment area.